So, Neil deGrasse Tyson sparked ideas back into infinities, and I'm going to try to get out like what here. I forget what he called them, transcendent infinities, I think. And so I have these flaws in number theories and number theory and paradoxes that arise, and they're hard to explain. And that 10 is not a number, and so every number is infinite. And the whole point of this video is to understand my exercises I use for strengthening my imagination. And so looking at transcendent infinities, and that every number is infinite, so I write it as 0.000 with an arrow, and that tells you that there's an infinite set of zeros ending in a set, and the set is typically 001. I use that as the lowest theoretical value that we could ever have. And I see that differently than I see 0. Because I like the idea of 0.3 repeating, and 0.6 repeating, and 0.9 repeating, all having their own unique values because we consider pi to have a value. And so you can take 1 divided by 3, and you get 0.1 repeating. Anyway, you get up to 9.9 repeating, and there's a flaw where if you take 0.9 and you add 0.1, that you get 1.0. So why, when you have 9.9 and you add 0.1, do you get 10.0? You should have 1.0, because 0 is technically a valueless number, and so 1 would be the next number after 9. And the whole point is with this is that I arrive at these paradoxes that because we have, say, 0.9 repeating, you can have a series of 0.0s to whatever decimal places that you lead your 9s to and your 0s to end in 1, that eventually then you add those together and you have, well, 1. But if you take 0.1 repeating and 0.9 repeating and add them together, you get 1.1 repeating. And that's saying that, how did I put it earlier? It's so hard to conceptualize all this because you're holding infinities and you have to correlate paradoxes. So the paradox is that why is 0.9 repeating plus 0.1 repeating equal to 1.1 repeating, when the 1 at the end is a 10, which you carry the 1. So logically it should be, well, a 0, which you cut off, and then 1, 1, 2, 3, 4, 5, 6, 7. And that just keeps repeating over and over and over again, however long your 0.9s are. And so every time we calculate 10, we are off by a 10th, which then it appears that you have 9.987655211, 98765, and it just keeps repeating over and over again. And that is correlating to however many times that you ignore 0.9 repeating and 0.1 repeating. And so in your calculator, how you break number theory is that you can add the 0.1 repeatings till you get to 0.8. All those are separate numbers until you get to 9. And then 8 plus 1, instead of becoming 9, becomes 10 technically. It's just, you gotta just ignore the decimal places, basically. And so if you start to ignore those decimal places, then you see why 10 is technically equal to 0. And so in understanding all of that, and how you look at point 0 repeating, ending in 1, how can we add that all the way up to 1? And how can you add that all the way up to pi? And so that's where you derive the concept of a fundamental value, because infinity is every single number until you add 1. And adding 1, technically, is then, well, 0. And so, logically, it's not technically 0, but you take that point O repeating, ending in 1, and you minus that by itself. And that is the same concept, it's just in reverse. And so, the way that I like to conceptualize this with thought experiments to strengthen my imagination is that I will use the same concepts of infinities, and they were similar to transcendent infinities, what Neil deGrasse was explaining, and I just didn't know about these things. So, to me, I had unknowingly studied this sort of thing, and that he says that infinities can have different sizes as well as a paradox. They really don't. Infinities are all the same. It's just that it's an illusion that they create more infinities, since every single number has an infinite amount of numbers that can equal the same number. And that is a huge problem in number theory, because it creates, just like I said, and that's the fundamental. I mean, what I'm trying to explain, at least as I see it, and how to find exact calculations. But this is about philosophy more, and how I derived this thought experiment, similar to a video I found online too, where they would show you how big the universe is and make you feel how small you are. But memory to suit, I don't know if I saw that first or not, and it maybe it planted some sort of recollective memory. I complicated who knows? Doesn't matter. So you imagine yourself as large as you could ever imagine infinity, and that's your brain. And you hold the universe inside of that, whatever that size is. And so you look at your hand, and the best way to expand on that is to imagine the distance of light traveling in the time it takes you to close your hand. So the idea is that you're so large that you close your hand, and your hand is traveling faster than the speed of light. Now, relativism aside, this is all philosophy, but you're just basically doing this. And so you're so large that doing that means that your hand is traveling faster than the speed of light. And so how big are you? Now suddenly you're bigger than what you were, because you're imagining something larger than infinity. And infinities, then, as you start to imagine yourself, say, holding a galaxy or something, if you know how long it takes a light pulse to get to you from a star or the sun, it takes, 5 seconds, something around there, for the sun to get to us. So you understand just how big that typically is. And now you're holding an entire galaxy. You can keep stretching that all the way up to holding an entire universe. You hold that in your brain, and now you hold all the physics. And so you imagine that same concept of infinity, except that now you need another infinity. Because you have your size, you can imagine another infinity. However big the universe is, you are still a value of 1 in an infinite set of numbers and an infinite set of calculations. So you shrink back down. Now you want to imagine the smallest infinite number that you can ever fabricate, and it helps to understand a little bit about atoms and subatomic particles. And so if you have a massless number and you like relativity, you have C squared, so then you imagine just how small a massless photon could be. Except what you're going to do is you're going to take that photon, and now you're going to explode it to the size of how big you were holding the universe. And so you are going to become that tiny little thing in your palm and the universe with all of its infinite size. is going to be, well, just this singularity, if you want to have a singularity, whatever it is. And you're just basically doing this and compiling it. And so after you can handle doing that in both directions, which it can be a headache it was a headache when I started doing it, then as you learn more about physics too, you start adding in things. So you're going to increase yourself. You're going to think about everything you ever learned, everything you know about physics, all the way up to your relativistic size and where you are. Then you're going to increase your size all the way up for everything you know about, cosmology or space, physics in general, just physics, all fields of physics. Okay, and then you just go up and down. Every time you learn something, you add it in, and so eventually, what it got me to where I could handle imagining just an infinite universe that's small, and eventually you start thinking about parallel universes and multiverses or whatever else you want to think about, how physics can correlate to all that. And so, to me, with how I see a paradox between infinite space and that our universe is supposed to be expanding, well, there's a paradox there that I derived through using the Big Bang for the artist's utopian society, that there's going to be one little particle that could potentially escape, and what's stopping another one and another one? So why aren't we losing matter that we can never receive again? Because if there's nothing out there, and there is technically all matter condensed into this giant singularity, why are we just a giant singularity? Obviously, to me, then, I conclude that we are expanding into a supercritical fluid state of black hole matter or dark matter, or whatever a black hole doesn't absorb is then absorbed outwardly into the supercritical dark matter sponge thing. So it's easier to just call it like an aerogel of dark matter to try and conceptualize it. And so physics here functions the same way that physics does in all the pores. That could be parallel universes or multiverses. It just doesn't matter to say that if there is an infinite amount, well, are there other versions of me? Through quantum entanglement, it certainly suggests so. However, we're getting to the finite details of entanglement now, so I can't be so imaginative anymore and enjoy just thinking. But that goes into where I'm at in subquantum field theory, which I can't say. I'm going to try to write a paper. We're going to delve into something called time memory, gravitational fields, and I believe my gravitational field model, since I understand exactly what they're talking about, maybe I can unify it with how I see mass energy equivalence and create the spherical matrix network that I envisioned a few years ago, that I thought would be a perfect way to calculate gravitational fields. So that, no, it's just really funky physics. It really just delves down into one of these other minute ideas I had about photons spinning in gravitational fields to maintain constant velocities, so that if you are warping trajectory, that mass does not change because it is spinning. So velocity is compensating for mass with energy and rotational inertia and shit like that. Well, there's probably no inertia, right? So that's enough. 15 minutes. I try to make these things